Alright, problem number 9, getting towards the end now. We want to draw the right Riemann sum, so an R sum with n equals 4 equals subintervals for the function f of x equals x squared plus 1 on the interval 0 to 2. That's a mouthful. We're going to do this without a calculator, so let's sketch ourselves a graph because that's always helpful. So x squared plus 1 is just going to be a parabola shifted up 1. Looking like that, going up. So if we're looking at it from 0 to 2 and 3, we're going to do 4 subintervals. We're going to split it into intervals of 0.5 because that's just 0 to 2. So 2 minus 0 equals 2 divided by 4 equals 0.5. So we do that, we split it up. Now when I go through, what I do is I just I go and I figure out my heights. But let's actually draw our rectangles first. So I'm doing a right sum. You put your right endpoint on the graph. Draw your rectangle. Again, right endpoint. Draw your rectangle. Go down. Sorry, this looks so crappy. Right endpoint. And right endpoint. Well, at least they're like consistently wavy. Okay, so figure out the heights of your rectangles. Well, that height right there at 0.5, just plug 0.5 into your function. So 0.5 squared is going to be 0.25 plus 1. We're going to get 1.25 right there. Again, plug 1 in. 1 squared is 1 plus 1 is 2. Okay, 1.5 squared is 2.25 plus 1. We're going to get 3.25 right there. Then our last endpoint right there, that height is going to be 2 squared is 4 plus 1 is 5. So now Riemann sum, our width is 0.5, so I'm going to have 0.5 times all of those heights, 1.25 plus 2 plus 3.25 plus 5. Go ahead and just evaluate that, and you will get 5.75 as the approximate area. And it's explained using words like blah, 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 blah. So these are circumscribed rectangles. They are an upper sum because they're an over approximation for this area. So 5.75 should actually be greater than what we actually find now for part B. So since we have the function x squared plus 1, just integrate that function, x squared plus 1 with respect to x, and you will get x cubed over 3 plus x plus c, but with our notation that we love, x cubed over 3 plus x evaluated from 0 to 2. So all we have to do is evaluate it at 2. 2 cubed over 3 plus 2 equals 8/3 plus 2, which is going to work out to be 4.6. Repeating, 4 2/3. So as we said, our approximation was a little bit more than our actual area.